Welcome back to the morning show. It's 7:25 and it's Wise Guy Wednesday, one of my favorite days of the week because Matt always makes learning interesting. Matt Sellen is here. He's our Wise Guy. We're continuing our hurricane theme. We were talking about how the rises and the evaporating water and stuff. Now you're going to kind of explain storm surge.
Right. Well, storm surge is when this huge wall of water comes on shore and wrecks everything, which is very bad.
We saw a lot of the storm surge.
Right, and there was like 20 feet of it or something down in the latest hurricanes. But it's very easy to explain this stuff, and it has to do with a couple of things. One is the fact that the hurricanes always rotate counterclockwise in the northern hemisphere.
Okay.
And this has to do with something called the Coriolis effect, and that just has to do with the fact that the Earth is rotating, and so we're not really sitting still, and so things look kind of weird to us. There's not a real force associated with this. It's kind of a fake thing due to the fact that we're turning. Okay. And so I just want to, this is how people can convince themselves that there is something called the Coriolis effect. Go to the playground, get on the merry-go-round, okay, those little things with a friend, so that you are sitting across from your friend on that little turntable-y merry-go-round thing, okay? Spin it counterclockwise, because that's the way the Earth spins if you're looking down on it from the north, from the northern hemisphere, and just try to throw your friend a ball. And the ball is going to go like this. If I was sitting there looking at you, the ball will go and it'll miss to the right. So no matter how you throw it to your friend, it's always going to deke off to your right and miss him.
So if you want to get it to your friend, you want to throw it to the left. And...
Right,
okay.
Right. So it's the same exact thing. In the northern hemisphere, anything that moves a long distance is always deflected to the right. That's the way it looks, and it's just because the Earth is rotating. So what happens is, as the winds converge on the center of the storm, they're deflected to the right. And so everything comes in and is deflected to the right, and that means that the storm itself is counter-rotating. It rotates counterclockwise. Okay. So you end up with this sort of storm wall thing, which defines the boundary of where the winds are very, very high. And right at that...
Which we call the eye.
Which we call the eye. And there, because of the rising air and the latent heat and all the stuff that we talked about in the first segment, the pressure is really low.
Okay.
And the pressure was 10% lower than atmospheric pressure in Rita's eye, I believe. I mean, it's a phenomenally low pressure. It went down by 3 inches of mercury. And when that happens, I can illustrate with this little sucky thing I have here, okay? If I stick this in, and that's this very technical term, if I reduce the pressure in here just by lifting up on this thing, the water comes up. Okay?
Okay.
And so what happens is, as the pressure above the storm is lowered by a lot, the ocean just rises up by several feet.
Is that as a result of the higher pressure around that area of
right. Outside you have higher pressure, normal pressure, and it sort of pushes the ocean up into where the pressure is lower by a couple of feet. And then you have these incredibly strong winds which are blowing counterclockwise, and so they just kind of take this bulge, as that bulge comes onto the shallow part of the ocean, and the winds carry it ashore. Exactly right. And so that's what the storm surge is all about.
This is where we get more deaths and more damage.
Yeah, generally it's terrible stuff. But
I have a question for you. We get asked a lot. People don't sometimes tend to believe me when I answer for them. Why, when it rained here Sunday, with all that rain coming from Hurricane Rita, why wasn't that salt water?
Well, when the water evaporates and goes up into the air, into the clouds and such, that you just get fresh water. The salt is left behind. You're sort of distilling the ocean water and turning it into fresh water.
Okay. That's what I thought, too. That's our Wise Guy explaining some of the science of hurricanes. We've been talking a lot about it, and a lot of people have been very interested in this subject all of a sudden.
Right.
If you've got a question for our Wise Guy, you can